Alright, so we're going to talk about acids. Acids are weird, y'all, because acids, they are covalently bonded. They're covalent compounds that break into ions when they're in water. So they're kind of not really covalent and not really ionic. They're kind of a hybrid. They're kind of both. So they get their own weird, special naming system. But I want you to think about them kind of as ionic because it will help you with the name. So if they are covalently, they are covalent compounds. But because they break into ions, we can really use what they break into to help name them, their pieces. So take a minute and look through this and see what you see. Do you see any patterns or anything like that? So most students see that they all end in the word acid, which is important. That they all begin with hydrogen, and that they all have this weird little thing over here. What is that? This, AQ, stands for aqueous, meaning dissolved in water. If I have something dissolved in water, what kind of mixture would it be? It would be a homogeneous mixture. Yeah, so this is a solution, a homogeneous mixture. But because an acid can only behave as an acid when it's in water, I have to write AQ for the formulas for them. So, two things to be an acid. Two things you need to be an acid. You need a hydrogen, and usually we put the hydrogen in front. And then you have something in the middle, and then you have AQ. So hydrogen in front and an AQ. Now, as you move forward in chemistry, or if you move deeper into it, you'll learn that not all acids have hydrogen in the front, and that's fine. But for right now, let's just put the hydrogen in the front, so it's like a big flag that says, hey, I might be an acid. You see the hydrogen in the front, and then you see the AQ in the end. That thing is an acid. We're going to name it with these special rules. Now, you may have noticed that some of these have hydro, and some of them do not have hydro. And then we also have these endings, ic and us, that we've kind of put on things. So how can I figure out what to use? It depends on what is here. This is going to be A for A minus or anion. So it's always going to be H plus, and A minus makes your acid. So we're going to break down our acid into H plus and A minus, and because all acids have H, the thing that names the acid is the anion, is the A minus. So two types of acids, binary acids and oxyacids. Oxyacids have oxygen. So if you have a binary acid and HCN, what I want you to think about this is no oxygen. So what am I doing here if I don't have O? Adding hydro. So you can think no O. If you have no O in your acid, then you say hydro. And in real classes together, I say no O, you say hydro. No O, hydro, no O, hydro. We'll learn it together that way, and we sound like we're in a party in the lecture hall. So no O, hydro. If you don't have oxygen in your acid, it gets a hydro in front. If it gets a hydro, it automatically gets an ic. The base name of the nonmetal, this is your A minus, okay? And then we'll put the word acid on the end. So your example here is hydrochloric acid. This is a hydrogen ion and a chloride ion. The chloride turns into hydrochloric. And then this is called hydrogen chloride. It's just kind of named like an ionic compound because it's a gas, not aqueous. So it doesn't matter if you have aqueous or not, how you're going to name these things. What if it's an oxyacid? What if it does have O? Well, then we get another naming convention. If the oxyanion ends in ite, what kind of things end in ite that you might know of? I'm thinking of polyatomic ions. These are polyatomic ions here for the most part. So if your polyatomic ends in ite, you're going to change the ending to us, and that's it. No hydro, no hydro. If you have O, okay, they have oxygen, so no hydro. But they get special endings. If the ending is "ite," it turns to "us." If the ending is "ate," it turns to "ick." And I remember this because Sprite is delicious, and I ate something icky. Or I have a colleague, she says, I ate something and it made me sick. Ate ick. Ite us. So here's some examples. And we can, this is a little multiple choice. Let's pick some multiple choice answers here. So this should be acid here. It's kind of like messed up a little bit. Ignore this. Okay. And assume that these all have AQ. This is what I get for stealing slides from a textbook. It doesn't have everything I want. Okay, go for it and choose A, B, or C for each one of these. Okay, so for number 1, this is no O, so it does have hydro, so you can immediately get rid of the rest. It must be this, hydrobromic acid. So let's think about it. It's H plus, and it's Br minus. What is Br minus called? Bromide. So it's going to be hydro, because it doesn't have O, ick, bromic acid. Hydro always goes with ick. What's next? Well, it does have O, so definitely not hydro. So what is this? This is H plus, and then CO3 minus. What's that called? That's called carbonate. Carbonate turns into carbonic acid. Ate something icky. Ate turns to ick. And then here, it does have O, so no hydro. We have H plus, and we have NO2 minus. What is this called? Nitrite. Sprite is delicious. Nitrous acid. You gotta learn your polyatomic ions for acids because they will make or break whether or not you can name acids. That's it. Now, to take the acid from name back to formula, I want you to write the ions out, but here's a hint. Check out the charge. Look at the charge of this carbonate, and look at how many H's there are. It's the same number. If this is a -1, look how many H's there are. So how many H's would phosphoric acid have with phosphate? So if I have H plus and phosphate together, how many H's would the acid have? 3. And what's the charge of phosphate? 3. Look at that. So it's easy to write the formulas for acids if you can figure out the naming system. The naming system is the hard part. So here's some acids you could just see, like, how do I write that thing? Why did I take sulfate? Why is it not sulfic? Why is it sulfuric? Because somebody decided it sounded good. Just look at this. If you put sulfic, I'm not going to count it wrong. So, you know, we're learning. And then here's a beautiful table, or the flowchart. This flowchart will get you through all the acid, base, all acid, ionic, and covalent naming you want. Make sure you can identify each. So your practice for this, I want you to write down, like, is it acidic, basic, or neutral? Or sorry, I'm tired. Is it acid, covalent, or ionic? Remember, molecular is also covalent. And then once you know what it is, then you know what naming system to use. So make sure you're identifying first, is it an acid, ionic, or covalent? And then you can go from there. So let's do a little bit of practice, a mixed practice. So try to fill in these blanks. So this is covalent or molecular. So that means I'm not going to do anything fancy with it. I'm just going to say what it is. How many N's are there? 2. Dinitrogen. How many H's are there? 4. Tetra. Hydrogen turns into hydride with that IDE ending there. Okay, potassium chloride. Potassium is a metal, so this is ionic. Now I need to write those ions. K is +1 because it's in group 1 and they make +1 charges. Chloride is Cl- because it's in group 7 and they make -1s. 1 and 1 makes a 1-to-1 ratio, KCl. What about this one? USCH and AQ, that means this thing is an acid. So I have to break it down. Look at the ions. Look at the pieces, because that's going to help us with the name. So what is this called? This is called chromate. So it turns into chromic acid because I ate something icky. And my last one, cobalt-3 cyanide. Well, that's a metal, so this thing is ionic. The cobalt has a charge of 3 because it's a 3 right here. There are not 3 cobalts. And then cyanide is a polyatomic, so I need 3 of them, so I have to put parentheses. There we go. Do it again. All right, so what do I got here? I got K+, I got Cr2O7 2-. This is potassium. And dichromate, because it's 2 chromiums there. Potassium dichromate. I got HBrAq. Ooh, that's an acid. Is this name right? Hydrobromic acid? Sure is. No O, hydro. Hydro goes with ick. Dinitrogen pentoxide. If you ever see those prefixes, you're only dealing with covalent stuff. So I have 2 nitrogens and 5 oxygens. Don't make it harder than it has to be. It's exactly what you see. PbO2. All right, so I know this is ionic because this is lead, right? But I don't know the charge of lead. I do know the charge of oxygen. If you put lead-2 oxide, you're wrong because you're crisscrossing and you're not looking at your math. So I have 1 lead, I don't know, and I have 2 oxides, which means it 4. So I have a lead 4 here, not lead 2. So make sure you're doing that math out for those ionic compounds. All right, you're done with writing and naming chemical compounds. Great job.